Okay, so today we are going to do a review for test number 2 for CSE 1322. And these are similar questions to what you're going to get. All of the questions in the test are going to be multiple choice. The ones in this test exam that I'm going to go through today, I didn't bother making up multiple choice answers, but you can make up some imaginary ones in your head. Choice A, 7. Choice B, 12. I don't care. If you can answer these questions, you're going to do fine on the test. The test does cover modules numbers 1, 2, 3, 5, 6, 7, and 8. It does not cover 4 because that's the GUI module, which we haven't covered yet. And it also does not cover 9, which is the one that we are working on right now, the data structures. So there are no questions on data structures, no questions on GUIs or graphics in here. All right, but everything else is fair game. And again, the types of questions that you're going to get are multiple choice or true or false or fill in the blank technically, but most of them are multiple choice or true or false. And you will be asked to answer about 39 questions. You'll have 1 hour to take the test. Okay. All right. So question number 1, this test is cumulative. So it does go all the way back to the beginning of the material. So we are going to start back with with module number 1. And so here we have, what is the output of the following code? And we have a Java block and we have a C# block. For the Java block, we have a string x equals ABC. It's the same in both codes. So I'm just going to do the first one, whatever that language is. So string x equals ABC. So just to be clear, I'm going to use my little scratch piece of paper here, and I'm going to say x is equal to ABC. All right, and then we have a loop, and it says int I equals 3. So I'm going to set up I equal to 3. And it says I less than 4. 3 is indeed less than 4. So I'm going to proceed into the loop. It says x plus equals x, y, z. So when you're doing a string concatenation, it's simply going to add it on to what was previously there. So we get x, y, z. All right. We've hit the bottom of the loop, so we're going to go back up to the top of the loop. And when we get to the top of the loop, we do have an I++. So we're going to add 1 to the I. I was previously 3. It's now going to be equal to 4. All right, so it says I less than 4. Well, 4 is not less than 4, so this loop is going to end right here and now. And at that point, it prints out the value of x, which means this is going to print out ABC, x, y, z. All right. Make sure that you don't take for granted any variables that are set in a loop. Sometimes we like to be tricky and say, for int I equals 7, I greater than 10, which that means that loop is never going to happen. So make sure you actually read the variables and check them. Don't just make assumptions and say this is going to run 4 times because you see I less than 4. That's not true. It actually only ran once. All right, so that is question number 1. All right, question number 2. I will post both this document and also the video right after class, so you'll have options to go back and look at it again. What is the output of the following code? So again, we've got a bunch of stuff going on here. We have x is equal to 3, we have y is equal to 7, and we have z is equal to 10. We have the character A is equal to B, the Boolean maybe is equal to false, and the string W is equal to low. All right, so that brings us to this big if statement. The if statement says if x plus y is greater than or equal to z and maybe or W equals low. All right, so you've got to think through how you are actually going to evaluate this. So on the left side, we're going to do the arithmetic first. So we have x plus y, x is 3, and if we add to that y, which is 7, then that's going to give me 10. So that gives me 10 greater than or equal to z, which is also equal to 10. So it looks to me like that first part over here, which I'm going to cross out, is equal to true. All right. So then we have true and then we have something that has to be evaluated in parentheses. So we have maybe. Well, maybe is equal to false. All right. And then on the other side, we have w dot equals low. So this is a string compare, and we're looking to see if w, which is low, is equal to the string low, which it is. So that is true. All right, so now we're going to do the logical one. Since we have parentheses around the true or false, we're going to do that first. So true or false is equal to true. And then that leaves me with true, and that is equal to true. So make sure you remember your order of precedence for doing math. Make sure you remember that after the precedence, you're going to do any comparison operators. After the comparison operators, you're going to do the logical operators, which are the ands and ors. So if that's not familiar, you probably want to go back and refresh your memory on all of that. All right. That did not clear the screen. Cool. All right. What is a constructor used for? Okay, so again, this is going to be something that will be multiple choice and you'll be given many different options. So what does a constructor do for us? If we have a class and the class has a constructor in it, then it is usually used to set parameters for that class. So if we have a bunch of attributes at the top of the class and we want to be able to set them, you will typically do it in a constructor. Constructors are fired only at the time that you make the class and never again. So the difference between a constructor and a setter is that you can call the setter as often as you want, but the constructor can only ever be called once, and it happens automatically at the time that the class is instantiated as an object. So constructors are used to set up variables, set up the basic state of an object at the time that it's created, and set any parameters that you need, whereas setters are generally used to change things later on as time is chugging along. All right, what is the difference between a default constructor and other constructors? All right, so the default constructor takes in no parameters. It's a constructor that just has an open-close parenthesis after it, and therefore there is no actual content inside of that. There are no parameters. All other constructors will take in some additional content that is then used to set things. All right, question 5. What does it mean to be an overloaded method? So this can either apply to an overloaded method or an overloaded constructor. An overloaded method means that you have multiple versions of the same method. So typically that's going to look something like you're going to have a void. It was so voidy the V didn't write. So we have a method called A, and it's going to take in an int x. And then we may have another version, so there'd be curly braces there. Then we may have another version of that method, void A, and this time it takes in a car x. Okay, this is an overloaded method. We have two versions of the method A. They just take in different parameters. To be clear, with regard to overloaded methods, the return type is not taken into account. So you cannot have a void A and an int A that take in the same parameters. That is not allowed. The only thing that is allowed is that you change the number, the type, or the order of the parameters in order to be able to have overloaded. The computer decides which one to call based on the parameters that you pass in. So in this case, if I call A and I pass it a number, it will run the first version of the method. If I call A and I pass it in a character, it will run the second version of the method. And if I call A and try to pass it in a string, it will, of course, give me an error because there is no such method. It won't compile. All right. So the type of method that is used or the type of parameter that is used to determine which particular method is going to actually happen. All right, what is the output of the following code? All right, so up at the top we have a class called justNumber, and it seems to set up an x that's equal to 3. And then we have our class main, which has two methods, one that's called change and one that's called changeJustNum. And then we have our main method down at the bottom. All right, so let's stare at our main method for a moment. It seems like we have an x equals 3. Now, something that's interesting here is that there's an x equals 3 in main. Okay, that is not in pen mode. Let's try this again. We have an x equals 3 in main. We also have an x equals 3 in justNumber. Please remember that those are completely separate and independent things. Inside of a class, if you have a variable, that class is separate and independent from the main method. And likewise, if you have a variable inside of a method that happens to have the same name, it's also completely separate and independent. So there's lots of x's here, but they're all actually separate things. And that's kind of the point of this question. All right, so down in our main method, we have x is equal to 3. So I'm just going to draw myself a little activation stack over on the side. No delay there at all. And in my main method, I have x is equal to 3. All right, my second line, I call change x and I pass it x. So I'm making a call to this method up here, and I'm supposed to be passing it in x, which is 3. So on my activation stack, I get a new one. It also has a variable called x, totally independent of the previous one. And since this is a pass by value, we are going to pass the 3 from the main method up to the changeX method. So changeX is going to take in that 3, and it's going to set its x equal to 3 as well. All right, so the first line in change x says x plus plus. That's going to affect this x up here, which is now equal to 4. All right, and then this method ends. And the great thing about a method is when it ends, it just goes away. And everything that's inside of it also goes away. So as this pops off the stack, that x that was up there, which got changed to 4, just disappears. All right, so back down in our main method, we are being asked to print out the value of x. So it says x is, and that's going to print out x is 3, because the x never actually changed. So the important part of this first block of code is we passed by value an x from the main up to the change x, and nothing that happened in change x had any effect down in main because x is a primitive type. And that's the important part there. Since x is primitive, nothing matters about what happened up in change x. But then that brings us to the next block of code. So we have justNum a equals new justNum, and then we make a call to change justNum. All right, so now we're making an object. The object happens to have an x in it. All of this happened over in main. So let me redraw my activation stack here real quick and just make it a little bit bigger. So we had the original x, which is equal to 3. And now we have a variable a, which is equal to, and you need to draw yourself a little object, and inside that object, there's an x that's equal to 3. All right. So now we make our call to change justNum. Change justNum gets an a. It's actually getting something of type justNum. And our method change justNum takes in justNum and calls it x. So it has an x, but what you need to remember is that that is just a reference, much like the links that we had in our linked list. It's just a link down to the block that's down in main. So in our method, just change num, or change justNum, we then say x.x++, which says start at x, which is this x up here, follow it and look for an x variable and change its value to 4 because it's plus plus in it. So the x inside the object got changed from 3 to 4. And so this method now ends, which of course will get rid of our activation stack, the top of it. All of that goes away. The link goes away as well. But the original object down on the bottom has now been changed. And so the last line asks you to print out other x is, and in this case, we're going to print out 4 because the x was actually changed. So to review, the first block of code, the 3 statements that are at the top of this method, they had no effect on the x when it went into and out of a method. But in the second case, because it is an object, the second block of calls did actually change x. So make sure you understand that. Yep.
Are primitive arrays passed by reference or value?
Are primitive arrays passed by reference or value was the question, and the answer is arrays are complex, so they are passed by reference, just like an object.
Strings that pass by value, right?
Strings are weird. They are technically objects, but they are effectively treated as if they are a primitive. All right. Okay, so that is passing by value, passing by reference, and hopefully that is a good review of that. All right, so that brings us to question number 7. What is the output of the following code? All right, so here, this is the example of an overloaded method. We have 2 different int a's, so we have 2 different methods called a that take in different parameters. The first one takes in an integer x, the second one takes in a character x, and then they each do their own stuff. So down at the bottom in main, we have answer is equal to a passing it 3. Okay, so let's deal with that one first, and then we'll come to the second one. So a passing it 3 down here at the bottom is going to make a call to this method up top, because that's the method that actually takes in an int x. So the 3 comes into the x, which seems irrelevant because that actually returns 7 no matter what. So that is going to resolve to a 7. And then we have plus, and then we have another call to a, but this time we're passing it the character b. So because it's sending a character, that's not going to call the first method, it's going to call the second method, which takes in a character. And then the second method says, if x is equal to a, return 8, otherwise return 9. Well, since b is not equal to a, it's going to return 9. So this method returns 9, and so that ends up with 7 plus 9, which seems to be 16 in my head, and when we print that out, we should see 16. All right? So important to understand, if you have an overloaded method, which one is going to get called. If there were 2 parameters in one of the methods and 1 parameter in the other method, then it's the one that matches the number of parameters. If there are 2 parameters and they're in different orders, then it's the one that matches the order. And it's up to the compiler to decide which one you're getting based on the order, the type, and the number of parameters that you're passing. All right. Next up, we have question number 8. Given the following code, which line in the following code will cause compile errors? All right, so we seem to have a class X. It has a private integer a protected method called getA, which returns an A, and then down at the bottom we have a void setA, which is public, and it seems to set the parameter inside of the object. All right, so this is giving us a block of code down at the bottom where we have a class Y that extends X. Okay, so first off, let's see. Can we extend X? Is there anything about X that would prevent us from extending it? And the answer is no. You're perfectly welcome to make a child class of any class. All right, so class Y extends X seems plausible. Inside of class Y, there is a public void B, which is just a method name. And inside of there, it attempts to do A++. Okay, so the question is, will object Y be able to see A++? So we have to go back to its parent and take a look at the definition of A. Well, A is listed as a private integer in the parent class. So will the child be able to directly change that A? The answer is no, because it's private. So this first line, line 1, will cause a compile error. So I'm going to put an X next to it because that's bad. Or I'm going to put a line right above it. Okay, I'm going to cross it out. How about that? That line is bad. You can't do that. All right, so the next line says get A, and it passes it a 9. All right, set A, and it passes it a 9. All right, so if we go back up to the parent, we do have a method set A that takes in an integer. That seems to be here, and that seems plausible. And that method is declared as public. So am I able to call that? Yes. So life is good here. Even if that method had been declared protected, I would have been able to call it as well. As long as it's public or protected, I'm going to be okay. So line 2 is okay. It's not going to cause us a problem. All right, so that brings us down to our main method. So in our main method, we create an instance of X and an instance of Y. And that's happening right here and right here. And then we're asked, can we make any of the following calls? So my X dot A is equal to 10. All right, so I'm trying from main to access X's A. And again, if we go back up and we look at X, A was declared private. So it cannot be accessed from a child. It cannot be accessed from main. So that method is not going to work. So I'm not allowed to say my X dot A is equal to 10. That is forbidden. All right, the next line says my X dot set A, and it passes it 10. So can main call the set A method in my X? Well, yes, it can, because it was declared public, so life is good. Had it been declared protected, if you're in Java and you're in the same package, then it would be allowed. If you're in C#, it would not be allowed. So protected would have been weird between the two languages here. So public, yes. Private, no. Protected, it's a little bit more complex. But in general, I can access set A because it's public here. So line 4 looks good. All right, so that brings us to line 5. So this time we're dealing with my Y, which is the Y object instead of the X object. Through Y can I access A? So the answer here is no. Y does not get A at all. Because A was private in its declaration up in X, Y never sees it. It's just not there. Now, in fairness, had Y been public, I would be able to see it on that line, right? Because it would be inherited down to the child, and then from main, I would be able to access it over in main. But in this case, A is private. Because it's private in X, Y can't even see it. So making an object of Y, I'm definitely not going to be able to see it. So again, line 5 is bad. So crossing it out. So that brings me to line 6, and this is the case I was just talking about. Can I call set A on object Y? And the answer is yes. So if we look at the definition for the class Y, there is no set A method. So you might think, well, you shouldn't be able to do it, but you can, because Y inherits it from its parent because it was declared public in its parent. So set A exists in the parent. The child got it because of inheritance. That's how inheritance works. And since it was public, even an object in main would be allowed to access it. So line 6 is perfectly valid, and you are welcome to use that. Which then brings us to line 7. In line 7, can I call the method B inside of my Y object? And the answer is yes. I can call that because it's a public method. All right? And that's not through inheritance. That's just a method that's declared in B. Now, to be fair, given that there's an error in that method, that would actually prevent me from calling it. But yes, you can call it from a protection standpoint. You just wouldn't be able to compile this code because there's many, many errors in it. So yes is the answer. You can call it as long as the error is corrected up in the original method. All right? So this one comes down to thinking through public, private, and protected, and who's allowed to see what through inheritance. And hopefully that's something that you guys are all familiar with, and it's mostly just a review for you. All right, question number 9. What is the name of the parent class for class X? All right, so we have a definition here which says class X, and then it seems to have a public int A and a set A. The question is, what is the name of the parent class for this class? There's none declared, so that means that your parent is object. Right, because all classes are children of object unless specified otherwise. So in the previous example, Y is a child of X because I said so, but X is a child of object by default. All right, so everybody's a child of object unless you specify otherwise. All right, question number 10. Is the following valid? Abstract class X, public int method A, open paren, close paren, semicolon, or curly brace, return 3, and then we seem to have a public abstract int method B. So let's talk about method A first. So the question is asking, can you have a method A which has a body inside of an abstract class X? And the answer to that is yes. Abstract classes can have any mix of abstract methods and concrete methods. This happens to be a concrete method, but it is a perfectly valid concrete method. So this method is all good. Life is happy there. The second one, on the other hand, is declared as being abstract. And if that were true, life would be good there as well. But it's not true because I declared it as abstract and then I put those curly braces. The moment you put the curly braces, the method is no longer abstract. So this will actually produce a compile error. Abstract methods cannot have any body, including just empty curly braces. That is still considered a body. So in order for this to compile correctly, it would have to say abstract int method B, open close parentheses, semicolon. That's how you declare an abstract method. But then it would be fine. Then I could have an abstract class with an abstract method and also a concrete method. All right, question number 11. What is the difference between an overloaded method and an overridden method? All right, so this is a common question. The overloaded methods are ones where we have multiple different versions of the same method with different parameters, which we've mentioned that before. An overridden method means that your parent had a declaration for a method and you didn't like it in the child and you changed it. An overridden method means that the child changed the parent's version of the method. So for example, we have in our parent class a method doStuff, and we don't like the way doStuff works. So in the child, we say public override doStuff, and we write a new version of it. Or if you're in Java, you do the @override public doStuff, all right? Public int doStuff, whatever it is. So overloaded means the same method multiple times and has nothing to do with inheritance. Overridden means it has to be inherited from somebody for you to be able to change something that you inherited from your parent. So that's the difference between the two. All right, how many constructors can an abstract class have? Okay, well, let's take out the word abstract and just talk about how many constructors can a class have, and the answer is usually as many as you want. You can have a default constructor that has no parameters, and then you can have as many different overloaded constructors as you need in order to accomplish whatever you're doing. So the question here is asking, well, does that change for an abstract class? Can you have a constructor in an abstract class? And the answer is yes, you can absolutely have constructors in an abstract class. You can have as many of them as you want, just like in a regular class. If I change the word to interface, then this becomes more complicated. In an interface, you cannot have constructors because they cannot be instantiated in any way. So abstract classes, yes, they can have constructors, but interfaces cannot. All right. All right, question number 13. What is the output of the following code, which somehow has random scribbles on it? All right, so we have a class X, and inside of our class X, we again have a public int A, and then we have a constructor for class X, which seems to take in a B and sets A to that. It also has another constructor that takes in a character and sets A equal to 10. Down at the bottom of that class, we have an override for toString, which just returns the value of A. All right, so down in our class Y, we extend X, and we call it from a constructor. So you can see that down in our Y class, we have public Y, which is a constructor for the class Y, which seems to take in an integer and calls super or base depending on your language. And then we have another constructor down below that, which takes in no parameters and calls super or base with a different value. So the point here is, again, we're down to matching the parameters that are coming in from main. So in main, when we opened the method, or when we created an instance of the object, we said y my y equals new y. It appears that I'm passing it a number 3. So the compiler is going to look at the y definition, and it's going to look for a constructor that takes in a number. And the one that matches that appears to be this constructor right here. All right, so this constructor is the one that's going to fire. The other one is not going to fire because of the matched parameters coming from main. But then this method is calling super in its parent or base in its parent, which means it's calling the constructor in its parent. And the particular constructor that it's calling, it's passing a x to it, which is a character. That's what's happening inside of that super call or the base call. So in the parent, we now have to look for a constructor that takes in a character, which is going to be this constructor right here. And that sets a equal to 10. Okay, so the weird thing here is the main method called a constructor and passed it an integer. That method then chose to call its parent's constructor and pass it a character. And even though there was overloaded constructors in both of them, it still knew which one to call, and we get our value set in A to be equal to 10 in this particular case. So after all of this, down in main, it simply asks me to print out my y. Well, my y is going to attempt to call the constructor, or the overridden toString method, and so we're going to get A is equal to, and in this case, we're going to get 10, because that's what it was set to. All right? So important to recognize, again, when you make a call to a method, if it's an overloaded method, it is going to match the type, the order, and the number of parameters and call the appropriate one. And that's true whether it's a regular method or whether it's a constructor. And in this case, if you want to call your parent's constructor, you use either super or base to specify which one you want, and you pass it the appropriate parameters. All right. The good news is we are done with Module 3. All right, so moving on to Module 5, which was everybody's favorite topic, recursion. What is the output of the following code? Public static int A takes in a variable called mynum. It says if mynum is less than 1, return 4. Otherwise, return mynum plus A of mynum minus 3. And all of this is started off with a call A5. When you get one of these, the first thing you're going to do is you're going to draw yourself an activation stack. And you are not going to try and guess what the answer is because you're probably going to get it wrong. Down in main, we have a call to A5. All right. When A5 is called, it has a method or a variable called mynum, which is going to be equal to 5. All right. So in our first version of this code, it says if 5 is less than 1. Not true, so it's going to go to the else line. And the else line says, and I really should have planned better on space, the else line says that you are to, we're just going to start this over because that's not going to work. All right. We're going to write over here. Okay, so we had mynum is 5, and it's supposed to return, I'm just going to abbreviate that to R, and it's going to return 5, which is my num, plus the recursive call, which is a of 5 minus 3 is 2. So it's making, don't do that, it's making a call to itself, and this time it's passing it 2. All right, so in the new version, that goes to sleep because it can't answer that question right now. In the new version, my num is equal to 2, said he confidently. And it starts off and says if 2 is less than 1, which it is not. So we're going to again go to a return statement, and it's going to return 2 plus a of, all right, so 2 minus 3 is going to be negative 1 is what it's going to pass up here. Great. So that's going to make a new call. This one's going to have my num is equal to negative 1. All right. So negative 1 less than 1, that turns out to be true. So the top one is able to return 4 because that's what the terminating condition tells it to do. So this is going to return a 4, and in the previous layer, what you do is you cross out your call and you replace it with the value that you got from the next call. So there's a 4 there. And then that layer pops off the stack, which I'm going to indicate by just scribbling it out. Okay, so the previous layer wakes back up again, and it's left with return 2 plus 4. Well, it can do that. So 2 plus 4 is going to be equal to 6. And so it was told to return that to the previous layer. So you cross out the original call in the previous layer and you replace it with a 6. All right. And again, the previous layer of the stack pops off because it's done. That brings us down to the bottom layer, which says return 5 plus 6, which is 11. And that gets returned back to main, which is going to print out 11. All right. So again, don't try to shortcut it. When you're asked to trace code, just draw the activation stack, keep track of everything like I just did, and you will get the right answer. Stop thinking about it and just actually trace it, and then you'll get the right answer. All right? So you're going to have at least 1 or 2 of those where you're having to trace code, so make sure you're able to do that for a recursive question. You'll probably also have a question where we ask you to fill in some part of the code that might be missing. And so here's an example of that. If we wanted to write a recursive method that counts from the number passed in up to 100, what terminating condition would go here? All right, so down in main, we have a call to A and we're passing it in 25. And what it's supposed to do is it's supposed to keep adding numbers to it. It looks like every time in the recursive call, it's adding 3 to it. So it'll be 25, and then it'll be 28, and then 31, and 34, and 37, 40. And it's supposed to keep going until you get to 100. So the thing that's missing here is a terminating condition. All right, so the question is, which terminating condition should go here? And we can see that there's a block of code missing. So our terminating condition is always going to be an if, pretty much. All right. There's a couple of hints in this question. The first hint is the terminating condition has to be something that's changing, and there's only one parameter coming into the method. So pretty much it has to be something related to my num, because that's what's coming in. So my num, all right. The way that this is written is this if statement wraps around the recursive call. So as long as this if statement is true, it's going to keep making recursive calls. So if you want this to stop at 100, you'll want this to specify that it stops when my num is greater than or equal to 100 was the vote. Okay, are we sure about that? So if my num is greater than or equal to 100, then do this work. Nope, that's not going to work because 25 is not greater than or equal to 100. So if you write it like this, that will actually do nothing because 25 is less than 100, therefore not going to work. So that's not going to be a less than, that's going to be a greater than. All right, so my num greater than or equal to 100 is going to cause it to stop. Everyone good on this? Y'all got really quiet in the room. That makes me nervous that I'm doing something stupid. All right, So this if condition will stop the recursion as soon as it's given a number that is greater than or equal to 100. You could debate whether the equal needs to be there because it does say up to 100, which is a little bit ambiguous. So this would include 100 if we were to actually get to 100, but the way that it's counting in threes, you're not actually ever going to hit 100.
Yeah, I was going to say, you need to flip it. It's less than it now. The alligator mouth opens the bigger thing.
I wrote it right, but I said it wrong. Is that what you're telling me? Oh, boy. All right. All right, I have been reliably informed that I'm an idiot. So apparently this is supposed to be that because I apparently cannot read my own writing, which is not surprising. All right, so if it is greater than or equal to 100, no, that's not right. My num comes in as 25. So the first time through this code, 25 greater than or equal to 100 is false, and the code will stop. It really is less than. It really was the way it was written just a second ago.
Wait, aren't we wanting it to return? Yes.
Okay, so I think what's causing the confusion here is this is not an if-else situation. This is just an if situation. So the terminating condition here is going to happen when that if statement fails. And we want it to fail when we get past 100.
I thought we were writing a terminating condition that would just return.
All right, we're going to just clear the screen, and we're going to rewind back to here. Never listening to you guys again. All right, if my num... It's always very scary when the room gets quiet because it's like, what did I do? All right, if my num is greater than... Oh, gosh, here we go again. No. Is less than or equal to 100 is the correct way to write it. All right, so to be clear, the reason that this is written this way is because this if statement is wrapped around the code that we want to happen when we are making recursive calls.
That makes sense.
If you wrote it as an if-else, I'm not sure what the else would be because all it's doing is it's printing numbers. So if it was written as an if-else, you're correct. You would need to reverse the logic in the if statement. But since it's just written as an if, you're going to keep going as long as this is true. And 25, which is what we were called with, is less than or equal to 100. So it does work. It then prints out 25, and it makes a recursive call with 25 plus 3, which is 28. 28 is less than 100, so it prints out 28 and makes a call to 31, and then prints out 31, makes a call to 33, and so on until it eventually gets to a number that's greater than 100, in which case it just stops and everything pops off the stack having done nothing to do because there's no additional work after the recursive call.
Okay, but what if we just did if and then return? Because it doesn't say, there's nowhere in this problem doesn't say that if is going around, but
There's a curly brace. You always forget.
Okay, the room does not like this question. All right, so could you write it another way? Yes, you could. You could say if my num is greater than 100, return
I thought the second curly brace was closing the
else. Yes, so either of those two options would work correctly in here, which basically says if the num ever gets above 100, then just stop. Otherwise, keep going, which I think makes everybody happier because there's an if-else, and you all believe there should be an if-else.
Yes.
But I promise you it works either way. And you definitely need to be aware of the fact that it can work either way. You can either have the if-else, or you can just have an if that is wrapping around the code that's going to happen when it is recursive. All right, are we all happy?
We're good.
All right. I'm happy if you're happy. All right, cool. What is the output of the following code? All right, so again, we're given a block of code, and it looks like this time we've moved on to exception handling. All right, so we have our method do stuff, and it has an array of 10 integers, and it says for I is equal to 0, I less than or equal to 10, I plus plus, and it is setting my nums at position I equal to I. Down at the bottom, we have a try do stuff, and then a print A, and then a catch for exceptions, and a print B. All right, so the question is, what's going to happen here? So let's start at the beginning. We do the try. We're making a call to do stuff. Do stuff starts off, and it creates an array of integers of size 10. The array of integers of size 10 will have cells 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Our next line of code says for I equals 0, that checks out. I less than or equal to 10, that's a problem because that means that loop is going to go to 10. And it shouldn't because the array only goes to 9. So that loop is going to go 11 times. This is the confusion of starting things with 0. Remember that it will actually go an 11th time into cell number 10. All right, so when it starts off, it's going to be fine. Cell 0 is going to get a 0, cell 1 is going to get a 1, cell 2 is going to get a 2, cell 8 is going to get an 8, cell 9 is going to get a 9, and then the loop is going to attempt to set 10 into cell 10. At the time that it does that, it's going to throw an index out of bounds error, or a array index out of bounds error, depending on the language. Exception, not error. That exception, because we are in a try-catch block, means that it is immediately going to stop execution at the time that that happens. All right, so the important thing here is the call to do stuff is what throws the exception. Inside of do stuff, an exception is thrown. So the way a try block works is immediately it stops execution and it jumps out and looks for a catch to deal with the exception that it just had. So to be 100% clear, that print statement will never happen. All right, the moment the exception fired, it stops executing everything in the try block and instead jumps down and looks for the first matching catch block. In this case, the catch block catches everything, so it's going to match everything and it's going to print B. So this block of code is simply going to print B. You'll never get an A because the exception was thrown inside of a try block, and that print A is inside that try block below where the exception happened. All right, so this time you get a B. Everyone good on that one?
Yes.
All right, cool. Moving on. Given the following code. All right, so we again have another try block kind of thing. So this time we're given a couple of different lines and we're asked to figure out exactly what's going to get caught here. So we're going to skip down to main for a moment and we're going to talk about what's happening there. And we're going to clear the screen because that's weird. All right, so public static void main. We have a try block, and inside there we're calling do stuff 3 times, once with a -1, once with a 9, and once with a 10. And then we have 2 different catch blocks, one that catches index out of bounds or index out of range, and the other one that just catches exception. All right, so there's 2 different possibilities there. One of them is going to print error 1, and one of them is going to print error 2. All right, so what is the output of this code? So we start off and we do stuff with a -1. And now let's go take a look at our do stuff method. So do stuff seems to take in that -1. It creates an array of 10 integers. And then it says, if x is less than 0, throw new exception. Okay, so x is less than 0, -1 is less than 0. So this is going to throw a new exception, and the exception is going to be of type exception, right? Because that's what was thrown. Remember, you can throw new exception. You could throw new index out of bounds exception. You could throw new IO exception. But in this case, I threw new exception. So this is going to stop execution immediately. The other calls to do stuff are never going to happen. It's going to jump out of the try block, and it's going to look for something that matches exception. The first thing does not match because index out of bounds is not exception, but exception is exception, so it matches the second one, and it's going to print out error 2. All right? The next question asks, what happens if you comment out line number 1? All right, so we pretend line number 1 doesn't happen, and we do the other code. Now what is the output? All right, so the same thing is going on. We're going to start off and we make a call to do stuff, this time with a 9. All right, so x is 9. It checks is 9 less than 0, which it's not, so we're not going to throw that exception. And similarly, we have a for loop, I is equal to 0, I is less than or equal to 9, I plus plus, and it does some work with the array. Okay, so let's look at the size of the array. It's size 10. That does mean we have cells 0 through 9, so 9 looks like it's going to be valid here. So what it's putting into the array is cell 0 is going to have a 0 plus 0. Or sorry, 0 plus 9, because 9 was passed in. So cell 0 gets 9. Cell 1 is going to have 1 plus 9, which is 10. Cell 2 is going to have 11. Cell 3 is going to have 12, all the way up until you get to cell 9. Cell 9 is going to have 18 in it. All right? And all of that works. There's no actual problem there. Just because we wrote exception code, that doesn't mean there is an exception. You actually need to trace the code and make sure that it really is going to happen. So 9 plus 9 is equal to 18, and that's going to print out 18. All right? So life is good on line number 2. Then we get to line number 3, which makes another call, but this time tries to pass a 10. So again, it's not less than 0, so it doesn't throw that exception, but we are now going to throw an index out of bounds exception because, again, we're going to try and access cell number 10 in the array. So on line 3, it's never going to complete that. It's never going to print out the value of cell 10 because it can't. It's going to jump out and it's going to print error 1. So to review, if line 1 is there, the code stops at line 1 and prints out error 2. If line 1 is not there, then it will print out 18 and then it will print out error 1. All right. Questions on that one? Everyone good? Yeah, you all look thrilled. Cool. All right, question number 19. What is the content of a.txt after the following code executes? All right, so now we're into file IO, it looks like. So we have a method here called writeFile, and we have a call to writeFile. Down in main, we're calling it with a.txt, the word test, and the number 4. So let's look at our writeFile method. It takes in a file name, it takes in a line, and it takes in an X. It opens up a file for writing, either using file and print writer or stream writer over in C#. And then it seems to have a nested loop that does for I equals 0, I less than X, I++, for J equals 0, J less than X, J++, and it tries to print into the file line followed by a space. All right, so the value of line is test. So let's trace this one for just a moment. So we have an I, which is equal to 0. We'll keep track of that over here. And we have a J, which is equal to 0. All right, so we go in and we try to do our first print. So it's a print, it's a print or a write, not a print line or a write line. So we're only going to print the word, and then we're going to print a space, and then we're not going to do a carriage return. So very specifically, line is equal to the word test. So it appears that we're going to write test and then a space. I'll just denote that with a little angle bracket. All right. The bottom of the J loop brings me back to the top of the J loop, and the top of the J loop tells me to increment J to 1. 1 is still less than 4, which was the value of X. I never noted that, but I probably should. X was 4 because that was what was passed in as a parameter. And so that's going to put me back into the loop, and I'm going to write the word test again and a space. J is going to increment to 2. I'm going to write the word test again. I'm going to do a space, and then J is going to increment to 3. I'm going to do the word test another time. I planned poorly once again. And so we have 4 tests on the line. Test space, test space, test space, test space. At this point, J gets incremented to 4, and we are done because 4 is not less than 4. So we jump out of the inner loop, and we're going to do a print line, which means that I'm going to do a carriage return, which puts my cursor back to the beginning of the next line, just like it does if you were doing a console reading and writing. All right, so at this point, we're going to go back in and start. We're going to go back up and change the I to a 1, and then we're going to start the J loop again, which of course is going to print test, test. I'm just going to abbreviate test, test, the same as the first line. All right, back to the bottom of the loop, we print a carriage return, brings us down to the next line. I goes to 2, and then we are going to print test, 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 and I think you can see what's going to happen here. We're going to get a 4th iteration of test, 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 and then I no longer is less than X, so that loop closes, and at that point we do a file close. And that means that we got test, 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 test 16 times in the file, 4 per line. No exception was thrown here, assuming that the file was writable. That's the only circumstance under which I would have gotten an exception. If the file was a not correct file name for whatever reason, or the file system was marked read-only, then I would get an exception, in which case it would put nothing in the file and it would print out the error message.
So when do you not have to flush from writing?
Okay, so the question was, when do you need to flush? And the answer is, anytime that you are dealing with a socket, you need to flush. But in this case, when I call file close, at that moment, it's automatically going to do the flush. So since I correctly opened and closed the file, I don't need to flush. The reason it's important in the socket is because you often want to send data to the remote side and then wait for a response before you close the socket. So in order for you to force that data to actually be written to the socket, you say print it and then flush, which forces it to actually send it across the socket so that you can get your response back in. Otherwise, it may wait until you close for it to actually send it. Truthfully, this file probably mostly got written at the point that I called file close. That's usually when it does the flush. All right. That brings us to question number 20. What line is missing below if this code is to read a file a.txt and print it to the screen? All right, so something similar happening here. We're calling read file and we're passing it a.txt. We get the read file, but inside of a while loop, we seem to be missing a line of code. So in the Java side, we set up a file and a scanner. In the C# side, we set up a stream reader. And then once we have that, inside of our while loop, we're supposed to keep going until something happens. And what you need to remember here is the syntax for how you know that you've reached the end of a file. In the Java world, that would be myscan.hasNextLine. HasNextLine is how you ask a scanner, is there another line coming? So on the Java side, the answer would be while myscan.hasNextLine parentheses. On the C# side, you actually tell it to keep going while you have not reached end of stream. So on the C# side, it would say while exclamation myscan.endofstream with a capital E, O, and S. And it's not a method, it's an attribute, so you don't put the parentheses at the end of it. All right, so while has next line versus while not end of stream. The other part of this to be sure that you remember is the way that you actually read in a line. We certainly could have changed this question to ask you what line was missing here so that you remember how you actually read one line out of the file. If you have a loop that's saying while has next line or while not end of stream and you never actually read from the file, then that loop will be an infinite loop and it'll do nothing. It'll just keep chugging and chugging and chugging without ever doing anything. So you have to make sure you're actually doing a read line to pull a line out of the file so that you're getting closer to the end of the file. All right. Question number 21. All right, looks like we've reached threads. So class doStuff implements runnable over on the Java side. Class doStuff is just class doStuff over on the C# side. Both of them have a method called run. On the C# side, you could call it whatever you want. And all it does is it prints out the word running. So down in our main, we have a creation of an object, which you always have to do. And then we have the thread creation, which in Java is simply thread x equals new thread with the object. In C#, it's two steps, thread start, ts equals new thread start, and you tell it the name of the object and the name of the method, and then thread x equals new thread. And then the question is, what's missing? So in order to actually have this code run, what do you need to do? You need to start the threads. So by creating the threads, which is what's happened here, that doesn't actually start them running. The last step you have to do in both cases is x.start. Lowercase start in Java, capital start in C#. All right. Be sure that you know the steps for creating a thread. It's not just the start that we might ask you. We might ask you to tell us the thread line where you actually make the thread, or the thread start line over in the C# world. And make sure that you understand, especially in C#, I always think that this syntax is goofy, where you pass in the name of the object. That bit makes sense, but then dot the name of the method without the parentheses, that's the goofy part to me. So honestly, every time I write C# code where I'm doing threads, I usually screw that up the first time and I have to erase it and retry it again.
Why do we have to import the thread class?
Why did we have to import the thread?
We don't import the thread class. We can just make an object.
So in C# I did. I said using system threading.
I'm talking about Java.
In Java, you don't, because you're just implementing an interface, the interface being runnable, which inherently does it all for you.
Got it. So when we implement runnable, we don't have to import the class.
Correct.
Right? Okay.
Yeah.
That makes sense.
Yep. All right. All right. And that brings us to the end of the document. All right. So this document has 21 questions, I think is what's on there. Again, your test is actually going to have 39. So there are many more questions on there. But the types of questions are fairly similar to what you saw today, and they're designed basically to test your knowledge of each of those topics. So make sure you understand how to set up a thread, make sure you understand how to read and write a file. We're not going to ask you binary files. We're not going to ask you socket stuff. We may ask you a high-level socket question, but we're not going to ask you to implement a socket or anything crazy like that. So if it wasn't covered in class, we're not going to ask it from the standpoint of stuff that we focused on in class. We don't ask questions on fork join pools or the TPL library in C#. All the questions on the multi-processing and threading libraries are going to be related to threading, not on the multi-processing side. So make sure you know the threading side, that's the one that matters. And then the recursion, which is obviously the other big one, just make sure you know how to trace recursion and you know how to write recursion. And if you can do both of those things, you'll be fine. Easy, right? Just write recursion. Boom. Why is this so hard? But you will have questions where you'll have to fill in the blank and stuff like that, like you've seen. So that's going to be the review for the test. You guys have a best of luck while you're taking it, and I will see you guys